A 1,000 liter container is approximately in the shape of a cube. Note that 1 liter, by definition, is exactly equal to 1,000 cubic centimeters. Let's answer some questions. So the first thing to do is determine the side length of this cube. We have a picture here, and it might be even more useful to realize what we're being asked to do. If it is approximately a cube, that means that this geometric shape has side lengths that we can call d. D high, d wide, and d deep. So the volume of a cube like this is simply d cubed. We'd like to figure out what is d. Well, one thing we can do is take our value of the volume in liters, take our 1,000 liters, and convert this into cubic centimeters given the conversion that we are told here. The way that I think about conversions often is to, first of all, think of this as being multiplied by some fraction. This fraction is equivalent to the number 1, and it just converts from one unit type to another. I want to get rid of liters, so I'll put liters in the denominator. I want to pick up, or now have, units of cubic centimeters. So that's what I typically will do, is I'll start with the unit conversion that I want, and I can see that if I do that properly, liters will cancel. I'm told that for every 1,000 liters, there are for every 1 liter, there are 1,000 cubic centimeters, or 10 to the 3 cubic centimeters. As it's set up, the liters cancel, and I get 1,000 times 10 to the 3. In other words, that's the same as 10 to the 3 times 10 to the 3 cubic centimeters, which is 10 to the 6 cubic centimeters. Now, I should consider the fact that I have a number of significant figures here. I know that the volume of this is 1,000 liters, assuming that all those digits are known. And so what I really have here is 1.00 times 10 to the 6 cubic centimeters. That's the volume that we'll start with. Now we can use our relationship between volume and side length. Apparently what we have is 1.000 times 10 to the 6 centimeters cubed is equal to the side length cubed. And since I want to find d, I'll simply take a cube root of both sides of that equation. The cube root, which I can think of doing like this, to both sides, take them to the power of 1/3. That's the same thing as taking a cube root. And what I find is this is 1.000 times 10 to the 2 centimeters. The centimeters cubed becomes centimeters, and that should give me d. So we're basically at our answer, and if you want instead, you could write this as 100.0 centimeters would be the side length. Or in other words, 1 meter is the side length. Part B. If the container is filled with seawater, with a density equal to 1.03 times 10 to the 3 kilograms per meter cubed, what is the mass of water contained within? We could look for equations here, or instead we could simply use unit analysis to do this problem. Noticing that the density is given to us in kilograms per meter cubed, let me take the volume that we had begun with, volume of 1.000 times 10 to the 6 cubic centimeters. I'm anticipating that converting this to meters cubed would be a convenient thing to do. And so I want to multiply this by some conversion factor. I want to multiply this times something that will get rid of centimeters cubed and give me meters cubed. To really drive home the point of what we're going to do here, let's instead make this abundantly clear by writing this as 1.00 times 10 to the 6. And remember that centimeters cubed is centimeters times centimeters times centimeters. That's a good reminder that when we go to convert from centimeters to meters, we have to do it 3 times. In other words, you can think of this as converting from centimeters to meters and doing it again and doing it again. It is for that reason that when we convert, we have a factor of 100 in the bottom, not once, not twice, but 3 times. And so our 10 to the 6 on top divided by 10 to the 2 divided by 10 to the 2 divided by 10 to the 2, with our centimeters canceling out and our meters turning into meters cubed. This is 1.000 times 10 to the 0. In other words, 1 cubic meter. Okay, now that we have the volume, we can straightforwardly multiply this times the density. Let's just check to see that those units actually work out. 1.03 times 10 to the 3 kilograms for every cubic meter. We have a volume of 1.000 meters cubed. You see now that the meters cubed cancels, and we get 1.03 times 10 to the 3 kilograms. I've rounded to 3 sig figs because that's our limiting number. So there is our answer. There you go.